Now let's see the second model, how to convert a number from base 10 to some other base, let's say b2. We have already seen how to convert a number from base b1 to base 10. Now we take the same number when we convert it to b2, then ultimately we have closed the loop. So from b1 we are able to convert the number to base b2. So the second step. Now let's take an example and I'll explain you. Let's take the simple one. Let's say we have number 10 or number 11. This number is given in base 10, and now the question is I want to find out its value in base 2. So we already know this. You might have done this many times. It is very simple. I'll just take an example for those who don't know it, and later I'll give you even some other way to do it. Okay. So now number 11. So when you have to continuously keep dividing it with 2 and then note down the reminders, and then we go in the reverse order and we arrange the number, right? So first we divide with 2. What is the quotient and what is the remainder? Quotient is 5, right? Why? 2 into 5 is 10 and the remainder is 1. And again divide it with 2. What is the quotient and what is the remainder? Quotient is 2 and the remainder is 1. Again I divide with 2. What is the quotient? 1. And what is the remainder? Remainder is 0. Okay. And again I divide with 2. What is the quotient? 0. And what is the remainder? 1. So whenever you get a quotient as 0, you stop there. And now you take all the remainders and then arrange them from bottom to top. So what do you get? 1 0 1 1. So 1 0 1 1 is the number representation for 11 in base 2. Got it? So this way you can do it, but the problem with this type of conversion is, if you observe it, the number of steps taken for this will be too high. If the number is x, let us say a number x is given in base 10 and you are supposed to convert the number to base 2, then how many steps are required? So if you calculate it, it will be log x base 2 steps, isn't it? How did I get it? If number x is as big as 2 power n, if the number x is as big as 2 power n, every division is going to make it 2 power n minus 1, 2 power n minus 2, so on, right? Every division is going to make it from 2 power n to 2 power n minus 1, and from 2 power n minus 1 to 2 power n minus 2, like this. So we are going to do this until this one becomes this power becomes 0, which means we are roughly going to have log x base 2 steps, and this is very big if you have a big example. So let me tell you how big it will be if you have some number like this. So if the question is given like this, given number is 32 base 10 and you are supposed to find out what its quotient is, what the number is in base 2, then I'll use the same method. So 32, when I divide with 2, what is the quotient? 16. What is the remainder? 0. And when I divide with 2, what is the quotient? 8. What is the remainder? 0. And again divide with 2, quotient is 4, remainder is 0. Again divide with 2, quotient is 2, remainder is 0. Again divide with 2, quotient is 1, remainder is 0. Again divide with 2, quotient is 0, remainder is 1. Now you put all of them from bottom up. So how many do you get? What do you get? The final answer is 1, 2, 3, 4, 5. This is 32 in base 2 if you go with the conventional method of converting it. But then don't do this. So I'll tell you some other method how you can do it easily, right? So first, before going to that method, I just want you to observe something. So whenever you have the bases in the powers of 2 or in the powers of 3 or in the powers of 4, like this. So if you want to convert a number between base 2 and base 16, or base 2 and base 4, or base 2 and base 32. So if this is given, so what does it mean? Both the numbers are in bases, which means one given number is in base 2 and you are supposed to convert it to base 16, which is in the power of 2. Or given number is in base 16 and you are supposed to convert it to base 2, which is in power of 2. Or if it is between 2 and 4, if it is between 2 and 32, if you have anything like that, you follow this method. I'll just take an example and I'll tell you how to do this. Let us say the number given is 1056. This is in base 16 and now we are supposed to convert it to base 2. So how to convert it is, you can observe that 16 is 2 power 4, right? You have to get it. You have to observe that clue first. 16 is 2 power 4. So what does it mean? Every digit which is in base 16, has to be represented using 4 digits in base 2. Every digit which is in base 16 has to be represented with 4 digits in base 2. You have to keep that in mind. Now let's take every digit in base 16 and let's convert it to base 2. You can either go from LSB or MSB, that is not an issue, but then you just see that LSBs will be in the LSBs here and MSBs will be in the MSBs here. You can go with any method. So now let me convert this one. 1. So 1, I have to represent 1 in base 2 in such a way that it is represented as 4 bits. So what is the 4-bit representation of 1 in base 2? 0, 0, 0, 1. Got it? And next one is 0. Represent 0 in base 2 in 4-bit representation. How do we get it? 0, 0, 0, 0. And again, next one is 5. So represent 5 in base 2 in 4-bit representation. How do we get it? 0, 1, 0, 1. This is 5. And what about the next one? 6. So represent 6 in base 2 in 4-bit representation. 0, 1, 1, 0. Therefore, this is the given number in base 2. Got it? So this is how you converted base 16 number into base 2, right? And now let's see how to convert a base 2 number into base 16. Let's say we have a base 2 number like this: 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1, something like this. This is the base 2 number. This is the base 2 number, and now I want to convert it to base 16. So here you should be bit careful. Earlier you directly converted it, but here you should be bit careful. So the method is same. So what is it? 2 power 4 is 16 power 1. So what does it mean? Every 4 digits in base 2 has to be represented using 1 digit in base 16. Every 4 digits in base 2 has to be represented using 1 digit in base 16. Therefore, you try clubbing 4 bits. Here you should be careful. Whenever you are trying to club 4 bits in base 2, you should start it from LSB, not from MSB. The reason is, if you start from MSB, you might end up with fewer than 4 bits in the last one. Then what happens is, you will try to add a 0, append a 0 at the end. What does that mean? You are appending a 0 in the right hand side. When you append the 0 in the right hand side, the number is actually multiplied by 2. Just now we have seen it, right? If I append a 0 in the right hand side, the number is actually multiplied by 2. But if you start from the leftmost side, if you start from the least significant bit, and if you keep on clubbing, even if the number of digits remaining at the end are not 4, if it is 2 or 3, and even if you add zeros to make it to 4, in the MSB, the value of the number doesn't change. Got it? Therefore, you keep this in mind. Whenever we are trying to convert it, we are just trying to convert them from the LSB, right? So you just club these 4 first, and then these 4 first, and then there are only 3. For that reason, you can append a 0 and you can club it. Got it? Now 1111, if you convert it, this number is equal to 15. So what is 15 in base 16? 15 is represented by F, right? And then 1110, if you convert it, this is 14. What is 14? E. And 0100, it is nothing but 8. So it is 8EF base 16. Therefore, converting a base 2 and base 2 to base 16 is easy, isn't it? And you can similarly convert between 2 and 8, 2 and 4, because they are all powers of 2. For example, if you want to convert, let's say 101 1 1 0 1 1 into, this is given in base 2. If you want to convert it into base 8, what do you want to do? How do you want to do? Now we know that 2 power 3 is equal to 8 power 1. What does it mean? Every 3 digits in base 2 should be represented as 1 digit in base 8. That is the meaning of it. Now what should I do? Club 3 bits in base 2. From where? From LSB, not from MSB. So just keep that in mind. Okay. Now that is the only way you can go wrong there. So append one more, right? So what is this number? So this number is 3. What is this number? This number is 7. What is this number? This number is, I think, 2, right? So this is 273 base 8. Is this a valid base 8 number? Check this. All the digits in this have to be less than 8. Yes, they are all less than 8. 7 is also less than 8. Therefore, the number is valid and we have converted base 2 to base 8. Got it? And how to convert base 8 to base 2? Let's see this again. Let's say this is the number given in base 8. You want to convert it into base 2. This is given in base 8 and now I want to find out what the base 2 is. How do I get it? Again, 2 power 3 is base 2 and 2 power 1 is base 2. So 2 power 3 is base 8 and 2 power 1 is base 2. So what does it mean? We have to represent every digit in base 8 as 3 bits in base 2. So how can we do that? Every digit here has to be represented as 3 bits. So either you can start from MSB or LSB, it doesn't matter much. So what does it mean here? 0 1 1 is here, and what about 7? 1 1 1, and what about 2? 0 1 0. Now check this. You got back the original number. Got it? See, and original number doesn't have 0 given, but then adding a 0 doesn't change anything, so you remove it. So you got back the original number. So that is how the conversions work. Now after knowing this, so one thing you have to be careful is, I am able to convert from 2 to 4 and 4 to 2 and 2 to 8 and 4 to 8 like this. Sorry, 2 to 4 and 8 to 8 like this. I am able to do it like this: 2 to 4, 4 to 2, and 8 to 2, 2 to 8, and 2 to 16. I am able to do all this, but then I didn't tell you how to convert base 8 to base 16. Actually 8 square is not 16, it is 64, or it is not in the powers, right? Then the best thing is convert this one to 2 and then from 2 to 16. You can do it this way. Got it? So anyway, what I mean to say is, if bases are in powers of 2, you can use the base 2 binary number as the intermediate form, and again you can convert it back, right? So this is how the conversion is happening between base 2s, and you can extend this method even to base 3, which means if you can convert from base 3 to base 9 directly. How? Every digit in base 9 can be represented as 2 digits in base 3, because 3 square is 9. Or you can convert between 27 and then 3, right? Every digit in base 27 can be represented as 3 digits in base 3, right? Vice versa, you can do that. Or you can convert between 4 and 16. So in the same way you can play with them, right? Now let's see what is the significance of this in converting a number from base 10 to some other base. Now let's get back to that point. Okay, so earlier I have shown you that in order to convert a number from base 10 to base 2, I'm taking a lot of steps to do this, right? So that is the reason what I want to do is, even though I want to convert a number to base 2, I'll try to convert it to a higher base like 16 and then convert it to base 2 again. This one will be easy for me, which means from base 10 I'll try to convert it to base 16 and then base 2. So let's see how it is easy. Now I want to convert this 32 only. 32 base 10 to base 2. But then I don't want to use that tedious method. So what we can do is convert it into base 16 first. So again the same rules. Whenever you want to convert it into base 16, how can I do that? 32 divided by 16. What is the quotient and what is the remainder? Quotient is 2 and remainder is 0. And then 16, when I divide it with this, what is the quotient? Quotient is 0 and the remainder is 2. Therefore, what is 32 base 10 and 16? It is nothing but 2 0. 2 and 0 is in 16. Now you convert this number to base 2. How can I convert the number to base 2? We already know that a number which is represented in 16, if a digit is represented in base 16, you have to use 4 bits or 4 digits to represent it in base 2, which means 4 bits have to be used for 4 bits. So what is 4 bit representation of 2? 0 0 1 0. And what about 0? 1 2 3 4. So this is 32. Sorry, base 2, value of 32 is base 2. Anyway, these two are insignificant, you can remove it. Therefore 1 followed by 5 zeros, 1 followed by 5 zeros. Got it? Therefore what I am trying to say is, whenever you want to convert a number from base 10 to a smaller number system, let's say like 3, then better you convert it to 9, because you have to divide that number with 9 nines and then convert it to 3, or it is even simpler if you can convert it to base 27 and convert it to 3. Like that you can choose among them, right? If a very big number is given, don't try to keep on dividing with 2, keep dividing it with 64 or 128 or 1024. Even you convert it into 1024 and later you convert it into the base 2, right? I hope you are getting it. But generally that big numbers will not be given in the exam, but it is worth noting this point. Okay, let me tell you one more example and I'll wind up with that. So let us say you are talking about 65 base 10 and I want to find out what its number is in base 2. If you go with this normal conversion, it will take a lot of steps, right? So what is the other way? You convert it into base 16 and then convert it to base 2. That way it is simple. So what can you do is convert it to base 65. I want to convert it to base 16. So when I divide with 16, what is the quotient? 4. What is the remainder? 1. Right? And when I divide with 16, what is the quotient? 0. What is the remainder? 4. Then you take this. Therefore it is 4 1 base 16 is 65 base 10. Now you convert this to base 2 easily. So how? Represent 4 in 4 bits and represent 1 in 4 bits. If I represent 4 in 4 bits, it is going to be 0 1 0 0, and if I represent 1 in 4 bits, it is going to be 0 0 0 1, right? So this is in base 2. So this is the value of 65. We got it easily. If you have to go with that method, you have to do a lot of steps, right? So now if a very big number is given, for example 1 6 7 8 9 1 0, something is like this. This very big number is given and you are supposed to convert it to base 2. This is given in base 10, you are supposed to convert it to base 2. Then the best thing is you go with bigger numbers and then divide it, and then you can, after getting the result, you can go with the base 2. I'll try to divide this one with 1024 and get the reminders. Okay, using calculator I'll do it. I'll try to divide it with 1024. If calculator is directly having base 2 represented, is fine, but then I don't know if calculator will be having base 2 representation for this. So in case if you don't have it, then divide with 1024 and then get the reminders, and then you write them bottom up, the reminders, and then you convert each remainder into base 2 later. Otherwise, if you keep on doing with that method, it is going to take a lot of time. Take a higher powers of 2, convert it into that, and then from there you can convert it to 2. That is what I mean to say. So this is how all the conversions work. And I didn't discuss about the fractions. Fractions also you can do it the same way. So okay, we shall do it later in some later floating point numbers. Okay, as of now we shall fix it to this, and we shall see some of the questions again, the examples, more examples. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.